Hey guys, welcome back to Technicos. If you are new to this channel, so I make content on SRE, DevOps and development. So you can watch my popular videos on JavaScript, on React, and a lot of videos I'm going to make on DevOps, SRE, so that it will eventually help you to grow in your career. So let's start what we are going to see in this video. We will create a Spring application. We will make a Docker image. It will be a single stage. I will explain what is it, and then I will make a multi-stage Docker image. Then we will optimize the size. We will push the image to the Docker hub or registry. Then we will pull that image and run to test if we can see the output. Okay. So this is how we create a Spring Boot application. We have selected Maven and the app name is simple demo. Let me show you the Spring application as well. So in src main, so we have the main Spring Boot application and a time controller. So when I start the application, let me just run it, and we have one endpoint as /time. So we will check that endpoint in http localhost 8080/time. We can see the app is running. The current local time is 2025 10:26 and time. Okay, so this is a simple Spring Boot application with a simple REST controller. To demonstrate how we can Dockerize this application, so we have seen the application. Now what we are going to do now, we have to build the application. So we will write the command mvnw clean package and we will skip the tests. So this will build our application. You can see we have got the build. So now we can clean this, and simply if you are using IntelliJ you can build from here as well, but I have shown you the command. And now the important thing is create a file called Dockerfile. Hit enter. It will automatically recognize that it's a Docker file. So what we are going to do now, we will write from OpenJDK and 17 JDK slim. We will use this image as a base image. Then we will write work directory /app. We will copy the build target inside the target folder that I have shown you just now. It should suggest, but in my case it is not suggesting. So we have demo, this one, app.jar. After that we will expose the port in which the application is running, 8080, and write entry point to run the application, java jar. Don't worry, I will explain each line very clearly so that you will never forget anything. Okay, we are done creating the Docker file. It's a single stage build. So we will open the terminal, and currently if we do docker ps, we can see the Docker is not running. We will run the Docker. So I will be creating one video on complete Docker in which I will explain you everything. So don't worry, I am expecting you to know little bit of Docker desktop and all in this video. But if you are not aware of that, please comment that you want a video on complete Docker tutorial. I will make it. So what we are going to do, we will write docker build -t and we will name this as demo single because it's a single build, and dot. Then we will hit enter. It's going to build the Docker file. So it's building. So my internet speed is slow, maybe that's why it's taking more time. Not an issue. So now the build is complete. We can do docker ps, we can do docker image. Inside this we can see we just created this demo single which is taking 673 megabytes, which is a huge compared to the application that we have. We are going to optimize it, don't worry. So specifically we can see it as well like this, images and then demo single. You can see the repository, tag, image ID, and when it was created. Remember this 673 MB. Okay, I'm going to optimize it, then you will understand how the optimization works. So what we can do, we can run docker run -d -p port 8080 and we have to expose port 8080 to Docker as well, and then demo single. So if I go to this and refresh, you can see we are getting the time. That means our application is running. If we do Docker ps, we can see the application is running, the image is running. We can just write this command curl and then http our endpoint to check, and it is showing that the current local time, that means the application is running inside the Docker. We can also do this docker logs and then container id. This is the container id. We will copy this and paste it here. When I hit this, we can see the application logs, the application is running. That means, so there is no issue. What we can do now to stop this, we can directly do docker and stop, and then again container id, paste. This is going to stop the container. If I do docker ps now, there are no containers which are running. I hope you understand how we can create Docker file, how we can run the container image, and how we can test it. Now the next thing that we are going to learn is how we can create a multi-stage Docker image. Before writing the multi-stage, I promised you that I will explain what are the lines doing. So this is base image. So what is the base image? This line tells Docker which base image to start from. Okay, so here we are using the Docker OpenJDK 17 JDK Slim, which is a lightweight Debian based image that already has Java JDK 17 pre-installed. So where we are getting these images? We are getting these images in the Docker Hub. So lot of people, lot of developers already build the images. If we search JDK or OpenJDK, so we can see we have OpenJDK, we have something called Ubuntu. Directly we can pull this Ubuntu image and use it. Similarly, we have Ubuntu Nginx. Similarly, we have something called Alpine, which we will be using in some of our video. So this is a very lightweight minimal Docker image based on Alpine Linux. So here we are getting this image, base image. Then we are defining the work directory. This sets the working directory inside the container. Okay, we are talking inside the container. So any following command after this, like copy or run or entry point, so will be executed from this directory. Okay, so if /app does not exist, Docker automatically creates it. It's basically the container's home folder for our application. After that, we have something called copy. So this is very simple. This command copies files from your host machine into the container. Okay, it copies. In this line, we are copying the jar file that was built locally and places it inside the container's app directory, because we set the working directory as app, and renames it to app.jar. So now our container has application code packaged and ready to run. We are exposing port 8080. So this line documents that the application inside the container will listen on port 8080. It does not actually publish the port. It's more like a hint for others who run the image. Where we run the container, we will explicitly map it. Like you have seen that I wrote something like port 8080. So while running, I expose both the ports. Okay, after that we have something called entry point. So this defines the command that runs when the container starts. Okay, when Docker starts this image, it executes java jar and then app.jar. So this will launch the Spring Boot application, and like we do manually on our machine. I hope this is extremely clear to you. I will comment everything and write the multi-stage file in this so that you will get everything in one place. So previously we have used OpenJDK for our base image. Now I'm going to use different image. I will tell you why, the reason. I'm going to use Maven. So let's define the base image from Maven as build. After that, we will set the working directory or directory /app. We will copy form.xml pom dot, okay, this should be pom.xml. So we are copying and downloading all the dependencies. Then what we will do, we will run maven dependencies. After that, we will copy the src. Then we will run maven clean package, and we will skip the tests. This is the stage 1 stage. Now we are entering stage 2, in which we will use Eclipse. So you can search Eclipse here, and we will use the Eclipse from Eclipse, and then we will set the work directory /app. We will copy from build, from equals to build /app/target, then demo 0.0.1 snapshot.jar app.jar. After this, we will expose port 8080 and entry point. Java jar app.jar. So once this much is done, now you will see the magic. We will do docker build -t demo. Previous one was single, then we will name it as multi. Docker build. Okay, I forgot to add a dot, so it's building. So you can see there are some errors that we are getting, and I intentionally did this to show you a very important aspect. We are getting this error in the second stage, which says fail to solve Eclipse, fail to resolve source metadata, and then this no match for platform in manifest not found. So what does this mean? So this error usually occurs when Docker cannot find a version of a specified base image that we are specifying here right now, and that image is compatible with your computer's architecture. Okay, for example, there are two major architectures, AMD and ARM. Okay, so in ARM64, we are in Mac OS, so it's using ARM64 or ARM64. The image that we are trying to pull is built on an AMD, or it supports different architecture. That's why we cannot pull and build the image. We did not get any error in case of OpenJDK 17 JDK Slim. The reason is it's a multi-build or multi-architectural build, so it supports both the AMD as well as ARM, but this image does not support. Similarly, if I build my Docker file in an ARM based architecture like in my machine and give it to you, and you are supposing some Windows laptop which is AMD based, and you cannot run it directly, and in cloud also, if you are using GKE or something else, you cannot directly run it. So the solution is multi-build. I have to make a build such that it supports both Linux, AMD as well as ARM. So this is a very common problem that I introduced you with. So now you have understood the problem and the solution. The solution is very simple. For if you are using any Linux or Windows, this base image would work for you. For me, it was not working. I have already mentioned what was the issue, so I have changed the base image. Simply what I will do now, I will build the image docker build t demo. We have named the previous one as single, we will name it as multi and dot. So this will take time and it's done. So we will do docker images demo multi. You can see the image size is 401 MB. The previous one, let me show you that one as well, demo and single, that one was 673. We have reduced the image size, that's really good. And this one is multi-stage. So I will explain what are the stages in what we are doing here. Don't worry. So in stage 1 we are just building the jar. So this starts from Maven image that already include JDK 17. Okay, we have that image. So we have given this name as build stage, so we can refer it. So this image is relatively smaller in size. Then we are setting the working directory. Every command after that would be stored inside the app directory. I already explained this. Then we are copying the pom.xml. This is the pom.xml where we have dependencies and all the things that you are a Java Spring Boot developer, that you are already aware of these things. Okay. After that, we are downloading all dependencies before copying the entire source code. So this step is very crucial for Docker layer caching. And why it matters? If you only change your code, not dependencies, Docker won't need to re-download all the dependencies to rebuild it. Okay, so it just uses the cached Maven layer. Then we are copying the src. We copy your project source code. Since this is usually changes more often, so you need to copy it after dependencies for optimal caching. After that, we run the Maven build command to package the Spring Boot app into a fat jar that includes all the dependencies. Okay, this is optional. This flag speeds up the builds by skipping the test execution, okay, because we don't have any tests. After this step, the jar will be available at target here in the target class. So after that, this is the stage 2 where we run the application. In this stage, this is the runtime image, this one that was causing issue. So this is a very lightweight version that only has the JRE Java runtime environment. It does not include Maven or build tools. Again, we set the app as the working directory inside the final container. After that, this line copies only the final jar file from the first stage, which is build stage, into the current stage. The rest of the heavy Maven file are discarded. Okay, that's the entry point of multi-stage builds. You build in a heavy image, then copy just the artifact into a lightweight one. Then you expose port 8080. So informs Docker and humans that the container listens on the port 8080. After that, we create the entry point to run the application. It defines default command that runs when the container starts. Very simple. Now we will run the application to test if it is working or not. Docker run -d-p port 8080 and port 8080, then demo multi. So now if we do docker ps, we can see it's running. And if we do docker logs and then do demo multi, okay, there's some issue. Just copy this. We can see the logs. What we can do now, if we come back to the localhost, if I refresh, you can see it's getting refreshed. So the application is working, the container is working, everything is fine. We can just do docker stop and the ID, container ID, it will stop. Docker ps to check if it is stopped or not. Yeah, it's stopped. So congratulations, you built the multi-stage Docker file and tested it. Now we will see some optimization, how we can optimize it. So to optimize, the first and very basic thing is to create a docker ignore file. So we will create that .docker ignore. This is very much similar as git ignore. So we ignore the unnecessary files. This is one good way of optimization. So let's see what we can do here. We have builder, its name is as builder, then working directory is good. We are copying the pom.xml, making it offline. In the second stage, we are using this image. So let's name it as runtime, and let's add a non-root user for security. So run add group, then system app group, and add user system in group. Then we are setting the working directory. and we copy only the build jar, no source, no maven cache. Then let's write something as run chown app user as app group app.jar and user app user. And what we are doing here, we give minimal permissions and we switch to non-root user. Before this line we will write use container support maximum RAM percentage 75.0. Again give a comma here. Now we are done. So what we are doing here, this one tells the JVM to respect container memory limit. This one tells the JVM to use up to 75% of available container memory for the heap. And we are setting some app user and app groups. Finally, if you can find some better base images, then that's well and good. That can reduce the image size as well. But for now, I haven't researched anything more better images than this. So this is the final Docker file that we are going to build again. So demo final, it's building. Just wait. So there's some issue with the permissions. Let me just fix it. So I just added 3 dash instead of 2. So let's build again. Docker build demo final. Okay, so it's done. So what we are going to do, we are going to show everything grep and demo. So we have a lot of things here. We started from 673 MB, we went to 401 in the multi-stage, and finally we ended up increasing the size, but it's still better because we are using some more security and we are implemented the docker git docker ignore. So it's fine, no issues. 41 MB is not much to bother about. Finally, what we will be learning to push this image into the Docker registry. So we have to do something like docker build x and then version. So we do have docker build x because this is needed to build multi-architect instance of the image. So we will do docker build x, create name multi-arc use. After that we are going to do docker login. So my docker identity or docker username is already there. So what I will do, I will simply write the command to build. We are going to build another docker image, docker final with latest docker final both for AMD as well as ARM64, and push it to the docker. So very simple, and it's going to do all the things for us. Let's see the progress. It's 32 out of 33. So if you are in Windows or Linux, you don't have to create multi-architecture build until and unless you actually want it to run on ARM and AMD all the machines. But what you can do, just simply build how we learned. You write docker build -t and then your name if you want, and then repository. This is your app name or what you have decided, and then latest. After that you just log in, you push that to the Docker hub, then you can pull it anytime. I will show you, and then you can run this command to test in your local machine. Very simple. Let's see, we are 23 out of 33, so it's going to take a little bit more time because it's a multi-architecture build. Now we can see the image is now pushed to the Docker hub. So we can go search your username. Okay. You can see demo final is there. What we can do now, we will just copy this command and try to open a different machine or something. Suppose I am in downloads file, and what I will do, I will just simply paste that command and it is going to pull the Docker image. So it's pulling, so it's done. Let me just do Docker images. We can see we must have something called this one. Okay, so what we can do, let me just run this image, docker run import 8080, and then the name of the image. I think that would be fine. Yeah, we can see it's running. So if we go to localhost port 8080 and go to time, we are getting the endpoint time, so it's working completely fine. So before ending this tutorial, I want to tell you what we have studied. We have seen how we can create a single stage Docker file, and we have seen how we can create multi-stage Docker file. We have seen how to optimize it. These things you don't have to mention if you are not much aware of how it is going to be used. Okay, so avoid using this. If you are completely aware how you want to use how you want the container to be used, then only mention these things. Rest are good. Thank you for watching. Please subscribe to my YouTube channel for such content.